so my projects for this class was to build a soil moisture sensing monitor that also collected atmospheric data. And the original idea was to be able to have some web-based acquisition, so we could, put this up on an Internet of Things website, like ThingSpeak or data.sparkfun. That didn't quite work out as I intended. There were some issues with that, but what I sort of worked through and came up with, I think, is a good sort of stepping stone to get to a point where eventually, hopefully, I can solve those problems. But for this project, I wasn't able to get the ESP device to work. And I'll explain a little bit about that in a minute. So what was the motivation behind this? My plants obviously don't look too good. This one, so what's the issue is that it's not getting enough water, and I forget to water, and people always forget to water. And so you want to have a way to remind yourself that you need to do something. One of the ways to do that is to build a device that can tell you when you've reached some threshold. And so the idea behind this device was to get some threshold of soil moisture so that it could remind me to water my plants, as well as tell me what the temperature is, what the pressure is, what the humidity is, what are the atmospheric conditions as well. Just because that kind of thing is interesting to me. But the way I went about fixing to solving this problem is to make something that is very visual, something that tells you when you need to water. I would like to be able to plot what all of this data is, because that's what we do. We like to plot our data, and to have the device tell me that it's time to do this. So my solution to this was a state machine to create something that was on a loop basis to collect this data, to check to see whether or not we hit some criteria, to then do some type of notification that we hit this criterion, and then to repeat that process over and over and over again. So right now I'm recording data, and I'll show you what this looks like in a little bit. So these were the components I used. On the far right, it's a BME 280 temperature sensor. It records atmospheric pressure, temperature, humidity, elevation, and for this particular version, it comes with two data protocols. So one is the I2C, and the other is the SPI. And I decided to use I2C because it minimized the amount of wiring I had to do, because as you can see, it was quite wiring intensive anyway, and so space was at a premium. So the other thing about that is, since this is a 3-volt temperature sensor, I needed to step the voltage up to, the board itself could only handle 3.3 volts. I need to step that up to 5 for the recording. And that's what this bidirectional logic converter did. So that stepped it up to 5 volts, and I was able to record it on the Arduino. The ESP Wi-Fi module was supposed to help me interface with the Internet of Things, but that unfortunately didn't work because I wasn't able to send commands programmatically. I could do it serially on my computer on the monitor, but I wasn't able to actually use the AT firmware programmatically to basically send data. And then the soil moisture sensor, which I have 3 of. So sort of, this is why the wiring is so, why I use the I2C, because otherwise I would have a bunch more wires. But up top is the BME temperature sensor. In the middle is the logic stepper. Then we have the LEDs. So the LEDs, and those at a certain threshold of soil moisture, which I set to be 25%, those will turn on. So if you get below 25%, they'll turn on. If you get above 25% soil moisture, they'll turn off. And I'll demonstrate that here in a second, but this is what the soil moisture sensors look like when fully hooked up. There's a lot of soldering. So in order to visualize the data, because I couldn't put it up onto an Internet of Things website where you could plot things, I wrote a Python module to import all the data, sort the files from the various times you run the experiment, and then plot all of your data as you wish. So if your temperature, this is from a 14-hour experiment in my house. So temperature C, atmospheric pressure, elevation, which I guess I bumped it because we dropped about 100 meters there. And then I didn't jump out anywhere. And then relative humidity. And so this is, it's a simple Python script to allow you to plot all of this stuff. And then soil moisture. So this is the soil moisture in my plant, which is dying, even though it's at 75% soil moisture. So clearly there's something else wrong with it. Yeah, so that was the goal, and it seems to have worked. It was first test type deal, but I was able to get all of this working except for the web-based interface stuff. So in terms of a demo, right now I've got perfectly dry sand, 100% saturated, more or less 100% saturated soil. So we expect these to be off or on when it's in dry soil. Let me stick it in here. That goes on. And I'll leave that one. Cool. I can't. Show it. So in my Python module, this records data to a file that you specify, and then when you want to plot it, you just choose whatever file you want. For this one, it was 1. And temperature. It's too big on the screen sizes. We change the screen size. There we go. Cool. Yeah, so temperature, pressure, elevation.
Recording for about 30 minutes, like
Basically, once I plug this in here, and so this is just this part of it, but then the soil moisture should shoot up for these two. Yeah, so this was a little test I did, but this one's basically 0 because that's still the same. These two don't. So, yeah. So I guess things that for future work, I'd like to be able to consolidate all this because this is a lot of wire and it's kind of complicated. I've got these alligator clip wires running everywhere. So consolidating this into a smaller, more compact device, putting it into a waterproof case so that you can use it outside, and actually getting the Wi-Fi module to work with as a person, something that's automated. Yeah, so So I think they have lots and lots of aphids on them right now, which I should tell Matt about because I think that's infesting our house right now. But there's something else that's killing these habanero plants. I don't know what it is. It's not a soil moisture issue right now, but I forget the water. So.
I want to know why your house went down by about 10 meters.
Did
you go down the stairs? What was that?
I thought that the elevation sensor was a pressure sensor, or maybe it's gravity. Is it gravity?
Elevation is computed from the atmospheric pressure, so atmospheric pressure changes show up as elevation changes.
So
that's
what.
Low pressure.
Well, so that's what I thought, right? But so that's exactly.
The pressure goes
if your
up,
pressure's
elevation
going
goes
up and the elevation's going down.
Yeah. Lower elevation, higher pressure. There's more.
So then, how does it deal with? Because this can resolve things to just pascals, like single pascals. How does it deal with like a low pressure system coming over? Do you just suddenly go up 10 meters?
You either know your elevation and you get atmospheric pressure, or you tell it what the atmospheric pressure is and you get elevation. They're fundamentally linked. So how did you calibrate your soil moisture is 0 to 100, something
Yep.
this percent? So how did you calibrate that?
I defined 0% saturation as completely dry F110, and then 100% saturation as colloidal F110. So basically up to the critical porosity where it becomes basically a mud. That was, and then the ratio of whatever. I made it, I just assumed it was a linear scale, which it might not be, but, and then took the ratio of whatever value I got out to the maximum, and that's my percent.
So 2-point calibration.
2-point calibration.
Cool. And, 59 degrees Fahrenheit, pretty cold in your house.
It's a little chilly when keep on the low side. Also, this is right next to the window as well, so that's what I'm sure that's what a lot of that fluctuation is, because it was.
Maybe that's why your plant's not.
Yeah, exactly. You think maybe it's a little cold for a hot weather plant?
Yeah, all my basil died when I left it by the window, so
Hmm.
I would leave it by the window.
I'll tell Matt that.
Yeah.
These are his plants.
Give it some blankets.
Any other questions?